So in this slide we want to talk about induced cup product. So we start with the cochain complexes CK and Cl, and then we want to talk about cup product on the cochain complexes passed on to the cup product on the cohomology groups associated with those cochain complexes. So these are the two cochain complexes CK and Cl, and I have written two respective maps in them which act on one simplices and take them two elements of a ring. And then I have also written the cup product induced. So let us write down the cohomology groups associated with the cochain maps which have just been written. So this is what we want to show, that this is that the cup product will also induce a map in the cohomology groups. So why is that? So first notice that the cup product of two cocycles is again a cocycle. So if phi and xi are cocycles, then their cup product is also a cocycle. Now cocycle means a map, say M is a cocycle if delta M is 0. So we have to produce delta of phi cup xi is 0 if both phi and xi are cocycles. So that is very clear. If both phi and xi are cocycles, then delta phi is 0 and delta xi is 0. So this term is 0. So therefore multiplication by 0 will give you 0. Then the second term is 0. Again multiplication by 0 will give you 0. Then in the end you add 0 plus 0 will give you 0. So you have proven that delta phi cup xi is 0. That means phi cup xi is a cocycle by definition of a cocycle. The second thing we want to show, that cup product of a cocycle and a co-boundary is a co-boundary. So this helps us sort out things in HK plus L. So things which are in co-boundary in either place will get transferred to co-boundaries, and co-cycles get mapped to co-cycles. So if you take a co-cycle and a co-boundary, then one of them has to be 0. Either delta xi is 0 or delta phi is 0. So in the first case where I have written delta phi cup xi, there obviously delta xi is 0, and the second case delta phi is 0. So both of them are co-boundaries. So precisely because they come from after application of map delta. So you apply delta on the cup product, you get these things, and therefore these are co-boundaries. So also notice that this thing is associative and distributive. So we essentially want to put a ring structure on it, a graded ring structure on these cohomology groups at certain point during this course, and therefore it is imperative to keep on checking this thing. So you have to start thinking of this now in terms of graded rings. So look up associative and distributive laws on graded rings, and then you put them back here and interpret it. So the only thing now remaining is to put an identity element. Now obviously the identity element has to be, say I have to write it as 1, and it has to come from the 0th cohomology group. So it is very simple. It takes value 1, and obviously it comes from the 0th cohomology groups. So therefore it has to take value 1 on 0 simplices. So the idea is simply this: you take two cocycles, you have to have a cocycle, because after all cohomology groups are defined by cocycles modulo co-boundaries. And if you take any co-boundary either in HK or HL, you should land in a co-boundary. Yeah, you should not construct any new co-cycle, and that is precisely what we are showing. Yeah, so you know, if it is a co-boundary, it has to come from delta of some previous map, and if it is cycle, delta of that map has to be 0, and that is pretty much it.